Welcome everyone. I'm Balázs Gerlei. I work at Security, a product company working on the customer identity and access management space. I work on SDKs for native Android, iOS, and also cross-platform Flutter and React Native, and we also do some white label applications. Now, today I'm going to talk about overcoming JavaScript Unsecurities in WebViews, which is basically a continuation of my talk from last year. Sorry. Wait. Just a moment. Okay, so last year I talked about more generic misconfigurations for the WebView and how those can be exploited, while I get most of the questions afterwards about JavaScript. So this year we're gonna talk about JavaScript. So previously on overcoming unsecurities. Oh, that felt great, I wanted to do it so much. So anyways, last year, just to recap and be clear that you don't need to watch the previous one to understand this one, but just to recap a little bit, I talked about why leaving remote debugging enabled for a WebView is a bad idea, that then anyone can access it via Chrome inspection tools. Also about allowing clear text traffic. I hope it's obvious why it's not a good idea, but maybe you didn't know that it's even if it was disabled in network configuration, it's not respected until Android 8 by WebView. And also about not enforcing HTTP strict transport security, which is only relevant if you do want to enable clear text traffic for some reason. Also, I talked about why not setting the base URL can lead to problems, mostly about same origin checks and failing of them. So you need to do that. There's a dedicated API for that. And also, I described how the file and content provider access is enabled by default up to a certain Android version, and why it can be a problem if you use the load URL with the file scheme. Today, this will come into play as well, but not directly with the load URL, but via JavaScript. And I also mentioned how not clearing cookies can be a problem, especially considering that the WebViews running on in the same process so they are sharing the cookie jar in the same process for the application. I also showed the breakout demo, which is fun to see, not that big of an exploit in and of itself. It's basically navigating away to a site that is not intended. Yeah. So I also, as last year, I would like to just briefly mention what are the components that we are talking about. There's obviously the WebView, which is a view. There's no Compose equivalent, but you can include it in a Compose via interoperability. But it's a view, and it's also an application running on the phone. By the way, I think since last year, I don't know if you noticed, that WebView, the application itself, is no longer updated directly together with the other applications in the Play Store, but there's a dedicated page, System Services, I think that's how it's called, and it's automatically updated by default, even if you disable the automatic updates for the other applications. So at least Google is pushing that the newest WebView version should be available on the phone. And there's these two clients, the WebView client and WebChrome client. Why these are separate, I'm not sure, but there are different callbacks for each to basically lifecycle-based events to react to. And the two things that will come into play most today is the should intercept request, which is before any network request is being made. You can react to it, and basically you say how you respond to it or stop it even. And the should override URL loading, which is kind of similar, but for opening URLs. Okay, about JavaScript, I mentioned it last year, but just briefly, basically just a couple of slides. The main thing I mentioned is that the rendering itself runs in the same process as the rest of the application before Android 8, meaning it can access the memory space of your application. And I also highlighted very much, and I want to highlight it again, that to run JavaScript with a WebView, you should use the evaluate JavaScript, not the load URL, which does work, by the way. So it's kind of a side effect that if you pass JavaScript scheme to it, it runs the JavaScript, but you should use the evaluate JavaScript. And I mentioned how you should sanitize the inputs, especially if they are coming from an untrusted place, and restrict the JavaScript bridge usage. And this last part, I leave it there. I left it there last year to restrict the JavaScript usage, but we will go into why it's important today. So yeah, as I mentioned, I received most of the questions about JavaScript, and if you're interested, you can watch the recording of last year's talks from here. Obviously not now, but yeah, you don't need the information, just I repeat it. So from now on, let's consider this fun enabling JavaScript for WebView. Many Stack Overflow posts, or let's be honest, today mostly it's an LLM that tells you to not do this to be secure, but if you actually want to run JavaScript, you need to do this. So from this point, I will assume that this is part of your code. Or probably it's something like this, because even Android Studio warns you nowadays that you shouldn't do this. But obviously, if you want to run JavaScript, that's what you need to do. Okay, so to run JavaScript with a WebView, you do kind of basically a headless WebView. I don't think it's officially called like that, but that's mostly how it's referred to. It's a WebView instantiated from code. So it's something like this, and as you can see, you can have the evaluate JavaScript, which returns you the result in the callback. So it's a callback-based API. It's a little bit hard to integrate with coroutines, for example, but it gets the job done. Technically, as I mentioned, you can do it with load URL, but you shouldn't. You should always use the evaluate JavaScript method. And then there's where you get the result for it. So let's go through some actual security problems that you might have if you have WebView in your application. And already I want to mention that we are probably native Android developers, and one of the kind of issue that if you use WebView, you kind of become a web developer in some fashion, especially if you run JavaScript. And we kind of relieve the same kind of problems that web developers did in 10 or 15 years ago. But already important to note that URLs are not necessarily web content, not necessarily point to web content, but they are URIs, so they can have different kind of schemes. I already alluded to the JavaScript scheme, and some kind of mitigation you might have to restrict what kind of web page is shown in your application is to mitigate based on the authority, basically the domain of the URL. But it can be passed, so the validation logic can be passed, even if the scheme is not HTTPS. So you should not just validate the authority, because you might expect something like this for the example.com, considering or let's assume that it's in a whitelist or a allow list. So, but you get something like this instead. With the JavaScript scheme, as you can see, the scheme is different, but the authority is the same, so it will pass the validation if you check only for the authority. Now, as last year, I brought some demos as well to show you this kind of stuff. Unfortunately, I won't share this one, but I will have another example at the end that will be shared. So just as the simplest form, that I have a button, but obviously in a real attack scenario, you don't need user interaction. Just to show you, if I press this button, that's basically throwing up this dialog from JavaScript. And how it's done, if you check it, pretty simple. The JavaScript just replaces the window location href with the JavaScript scheme and the example.com, and this demo also has authority validation, so it passes it because it has the same domain, but it has some JavaScript appended to the end. Now, the tricky part about this one is if you do this, the sudo var URL loading is not even called. So what I found, at least, is the only way to really stop this is to inject some JavaScript yourself to the WebView. Something like this, or maybe in the slides it's more clear. So something like this, to override the href setting. And then if you look at the middle, when the scheme is not HTTPS or it's JavaScript in this fashion, then you don't call the original method. Then it will be called even from JavaScript side. But other mitigations, of course, validate both the scheme and the authority together, and only allow the schemes that you want to support. Even my example is not the best, I think, because you should always prefer allow list, not block list, so not filter out what you don't want to allow, but rather just specify what you want to allow and only go forward with this. And I already want to mention, this will come back multiple times, the real-time validation. To understand this is that basically the lifecycle callbacks methods are called in certain places, like before loading the URL, but I will show you in a couple of minutes that some time-based attack can avoid that. So it's always better to use real-time validation. So before any sensitive operation, check the current URL of the WebView. And as I said, be aware that the window location href, if it's set with the JavaScript scheme, then the sudo var URL loading is not called. The other thing is, let's say you want to publish files to the WebView. There are multiple ways to do this, and one of these is XML HTTP request. Now, if a WebView has file access enabled, which, as I already mentioned, is by default enabled up to a certain Android version, and the attacker can control the actual path of the file that's being accessed, then it might be exfiltrated, or the way to open arbitrary links with the file scheme. So let's imagine this one. This is how simple XML HTTP request is made from JavaScript. As you can see at the top, it's created. And then basically it opens a file URI from the asset folder of the application, and then prints out an alert. Let's actually see how it works. Again, press the button, and what it does is basically prints out, I tried to make something semi-realistic. It prints out some kind of configuration. If you check the asset folder of the application, of the demo, you can see that here's this app secret config that might be in an application containing a seemingly secret key, which is now displayed in a WebView. And the JavaScript side for this is this, the important part I already showed you on the slides. Basically, if it has file access, it can make this kind of XML HTTP request, and the file will be passed back to the WebView. The mitigations, if you don't want to publish the file, you just left it by mistake, then the obvious mitigation is to disable the file access. And as I mentioned, it's disabled by default since Android 11, but if you have to support all the Android versions, you need to disable it manually. And you also need to disable two things, to be clear: allow file access and allow universal access from file URLs. The second one is important because this contributes to a cross-origin access. So disable both these, but of course, if you want to publish files, this is not the answer, so let's go forward. There's also this wonderful construct called web resource response. This allows you to basically emulate a server, so to respond to any requests that is being made in a WebView. You can basically intercept the request and basically create a response with the status code, content type, so on, and the response body as well. This one is an example, but I brought this for you most to scare you. And now that you are adequately scared, I will tell you that this is actually from a real case study that was done against an application. This is how it's simplified a little bit, but this is how the application was implemented. And don't want to go too much into it, but this is the should intercept request that I talked to you about already. This is a lifecycle callback that's being run before a request being fired, and the implementation is basically answering the request with a file using the web resource response API. What it does is basically expects, if you check it a little bit, if it expects a file URI appended to the end of the URL that's being made, and it extracts that and uses directly that to access a file. The problem is, of course, here that the caller is basically can influence what kind of file URL is being used. But also not just that, it's quite complicated and cumbersome to do this. If you check this, basically you need to create a whole response with also remembering the cross-origin checks and also the 200 HTTP code, a lot of boilerplate. So there's a much better way to do this. But before that, this would be a POC attack that basically, if you check it, it defines a function at the top, it's JavaScript function, to create, again, the XML HTTP request that we are familiar with, but it opens the file with the domain that is probably in the whitelist, and it appends the file URI to the end of it. But in the callback at the bottom, I think I highlighted it. Yeah, so the callback at the bottom, it basically makes another call when the file is returned to the JavaScript and returns the file to the attacker website. So it exfiltrates the file like this. And as I said, it was actually being done. I don't want to necessarily pick on any application, but if you look close enough to the URL, you can have an idea what kind of application this happened to. Mitigations. Basically, there's an accompanying API to the web resource response, which you should always use. It's part of the Android X.WebKit, and it not just protects you from these kind of attacks, but it also, as you will see in a moment, it simplifies the implementation a lot. So always use WebView asset loader together with the web resource response. It allows you to safely process the data and basically come up with the URL path. So you don't need to expect the URI appended to the end, but you basically set up how the URL will be and what kind of file it will be accessible. So, for example, you can publish an image from the assets folder of the Android like this. You can see it is /asset/image PNG instead of expecting this whole file URI appended to the end of the regular URL. And it's compatible with the same origin policy, so you don't need to manually do that. There's some reference documentation for that you can check out. And it will simplify the thing that I showed you before to this. So you parameterize the web asset loader with a builder pattern saying what kind of path, what resource would be accessible. And then in the should intercept request, you just forward the call to the asset loader instead of all that stuff that I showed you. Yeah, like that. Okay, we need to talk about cross-site scripting, and this harkens back, or this refers back to what I already said, that once you have to implement WebView, you kind of become a JavaScript developer. The problem, though, is that on Android, the cross-site scripting, which is really just injecting client-side script into, scripts into web pages that will run on the client side. The problem, or the reason why it's more powerful and also dangerous at the same time on Android, is the existence of the JavaScript interface. That means that the JavaScript potentially can talk to native code, and then the native code will run in the as the application, basically having the same rights. And you might not expect that. And also you might not expect that the origin of it is not really checkable. Effects, of course, may vary as the normal cross-site scripting as well, from pretty nuisances like showing a dialogue, or it can be quite significant depending on the sensitivity of the data that can be accessed via the JavaScript interface. As I said, that's how it's the most problematic on Android, because on browsers, if you think about it, they are running in a sandbox. So they are, for the most part, they cannot break out of that sandbox. But as soon as you add the JavaScript interface on Android, they will be able to call native methods. So you add the JavaScript interface with the add JavaScript interface method that injects a custom class that you create to the WebView. But it's already important to note that it injects it to all frames of the web page, the iframes as well, not just the embedding side. So that's you need to be aware of, especially if you have content that you are not in control of. It injects, or it makes accessible the methods of that custom object that you pass to it, at least the ones that are annotated with the add JavaScript interface, at least on modern Android. Let's get back to it later. Fields are not accessible, so only the methods that are annotated. And even the Android documentation warns you about this, so that basically the Android application cannot verify the origin of where the request came from. So the trustworthiness cannot be really checked. That's why you kind of have to assume that it has malicious purposes when you receive it. Broadly speaking, this is how it looks like. There are three components of the JavaScript bridge. The custom class that you define that I mentioned. There's where it's passed to the WebView, and you have to provide a name for it, how it will be accessible from the JavaScript side. It's probably in an activity or fragment. And then the script side, at the bottom right, you can see that it refers to the JavaScript, the custom object that you pass to it, the same name as you passed into the add JavaScript interface method. And again, the methods that are accessible need to be annotated with the add JavaScript interface. As you can see from the demo, maybe you already have an idea why this is a problem in our demo, but let's see it. So again, we have this nice button, and when I press it, it throws up a dialog. Surprise. Again, a pretty nuisance. What I really want to show you, though, is the more complex version of this. So for that, I need to modify the code, but let's see what it does. So it has the JavaScript interface as I showed you, and it has this get session token method that returns a session token, which should be a secret. Well, imagine that this is meant to be only accessible by a website that you control, but somehow it is accessible by a different website. And you actually show you this. I need to modify and call a different JavaScript. Run the application again, but while it's compiling, let's show you this normal example, the simple one. On a button click, it basically just throws up an alert and accesses the JavaScript interface. Nothing fancy. The problem comes when you combine it with timing-based attack, and this is how the real-time validation of the current URL will come into play as well. If you check this JavaScript, what it does is basically it has the same function that throws up the alert dialog, but it only fires it with a timeout. So it's asynchronous, and before it's being executed, it renders another navigation. And what it does is basically replaces the window location.href with a site that is probably in your whitelist. So let's imagine that this is a site where you not intend to pass that same token to, but it loads the site that is in the allow list. And after a delay, it runs the JavaScript. Again, this is a time-based attack, so it relies on a race condition. So if I show you, it might not work first time, but hopefully it will work. Oh, I didn't. That was the other demo, I see. Yeah, I didn't switch because I already on the application. So if I press it, it either loads the web page, which it doesn't right now, but here, the second time I succeeded. So it didn't load the web page in the background, but ran the JavaScript before. And the reason is that if you check the implementation, here in the should override URL loading, we call this setup page method, and there we validate the URL, so check the allow list. And if it's done, then only then we add the interface. And if it's not, we remove the interface. Okay, I cheated a little bit, I added a strip to maybe make more successful with the race condition, but it can happen without that as well. So we add the token if it's in the allow list, and then the supposedly known website can access the token, but as you've seen that it's not certain that that's what's accessing it. What you could have done, but I meant about real-time access check, is here you can actually call the current URL via the get current URL. No, sorry, get URL method of the WebView and check it before a sensitive operation. That should return the real one. But JavaScript interface used to be JavaScript bridge used to be way worse. So before Android 4.2, you don't even need the add JavaScript interface annotation. Any kind of method was accessible, and even reflection could have been used to call basically any kind of methods. I bring you a little example which used the Java lang runtime to call basically native, or in this example, for example, a shell script run on the other side, remote code execution basically. This one only places a hello text on the phone, but you can imagine something more destructive. Hopefully this is no longer relevant to you. Hopefully you don't need to develop applications to support before Android 4.2, but if you do, then, well, I don't know, reconsider or work on your CV a little bit. Okay. Mitigations. As last year I mentioned, restrict the JavaScript as much as you can. Basically, this is what I meant. So only implement logic there that you actually want to allow, and also always think about the caller being malicious. Only annotate the necessary methods with a JavaScript interface, and prefer the real-time validation to check the actual current URL before the sensitive operation that you run in the context of your application. And you can also combine this with the lifetime-based checks, but always use that as well. And lastly, you can only run JavaScript package within your application, which is always the better idea, because then you can trust it mostly. I mean, except the application being repackaged, but that's another kind of security problem. Yeah, so another thing. I talked about this last year as well, but then I was talking about when the URL is passed to the load URL method. Now, other Android components can be accessed as well. And you may actually want to offer this functionality. For example, I've seen this with mobile device management applications. I don't know if you're familiar with those. Those are like bring your own devices to the companies. And in that case, sometimes the company wants to protect the resources or web pages, web services or applications even, with the client-side verification, basically endpoint verification. So there is a client that's running on the phone, and the web page, for example, can check whether that client is installed, and if not, then it can forward to the Play Store to be downloaded. So that's why you may want to actually offer this launching URLs, for example, in an external browser from the JavaScript, from the website. But it may be abused to launch arbitrary components like activities, because again, HTTPS is not the only URI scheme. Intent URI scheme exists as well, and it's supported by Android, but it can have the component and selector fields where a certain component can be specified that will open the URI. To show you this, back to the demo. What we really see here is if I press this button, another activity is opened. And why this is important is that this secret activity is set to be not exported, so it should not be accessible by, outside of the application, but the native code after the JavaScript bridge runs in the context of the application, so that of course can access this activity. This is how the implementation, the naive implementation might look like, and you might encounter first the parse URI method of the intent. But this one takes these component and selector fields into consideration. So with something like this, you might expect something like this, a URL, but you might get something like this instead. It has the intent scheme, as I mentioned. You can check it here, the intent scheme at the beginning, and it also specifies the component field to be one of the activities of your application, the secret activity in this example. So basically, what you can do is to null out explicitly the component and selector fields after the parse URI code, and you can also add the category browsable, which is meant for activities that are meant to be opened from the web. Or you can also, or additionally, you can also check for the exported flag of that activity before launching it. So use the resolve activity info of package manager, intent to check the exported flag and only launch the activity if it is exported. But even better, you don't need to use the parse URI method. I would even say in this case you shouldn't use the parse URI method, because there's also an intent constructor that can be used in this case with the action view action, and you can pass the URI. You need to parse it from the URL string to URI, but you can pass it, and this one does not take the component and selector fields into consideration. So it will be opened in a external browser, for example, or at least pass the URI to the other activity as data. So again, think through the functionality what you want to provide, like in the MDM's case that I mentioned, and use the constructor of the intent if possible. Explicitly set the component and selector fields to null, although if you use the intent constructor, you don't need to. And you can as well check the exported status of the activity that you want to open, which is always a good thing. And finally, JavaScript engine. I'm really happy about this, because last year I showed you even that it's in beta or alpha, I don't remember, for so long, but it's actually very recently released. If you can check it, it's this summer, Google released the 1.0 version of this. So now if you want to evaluate or execute JavaScript when you don't need to display anything, you can use this library, and it provides finally multiple isolated environments with relatively low overhead. So the different JavaScript runs cannot know about each other or the application. It's also, the API is very nice. It's asynchronous based on listenable features, so it can be integrated very nicely with coroutines. Still uses WebView in the background, so the application itself needs to be installed on the phone. Again, it's now more updatable, or at least more likely that it's updated, but yeah, it might be an older version that doesn't support this, but you can at least check for it. And it also can be used in a service, so it no longer requires an activity context. I'm not sure I mentioned this time, but the headless WebView case even, it needs an activity context to run properly. And it's available for Android 8. Now, the last point is blessing and the curse. At the same time, it cannot make network requests. So it's good because it protects you from any JavaScript calling out to the web and exfiltrate data like that, for example. But if you want to do network requests, then this one you cannot really use. To do this, I actually brought you a different demo. I tried to do some kind of realistic examples, realistic use case of password strengths. Now, I've worked as a password manager before, so I need to take myself back from ranting about password strengths, because it's really a bad thing. Just a little bit, let me. So if you, for example, include a dictionary of not safe passwords in a password strength calculator, then an attacker needs to just exclude that dictionary, and then we just made their job easier. So that's one thing. And also the 1 to 4 value account, how strong is the password, is not really usable for creating a good password, forcing the users to create a good password that is not brute forceable. It's really easily tricked, as you can see. For example, I enter my actual password to it, and it will say, okay, but you can check the password, it's nothing. So of course that's not our actual password, but as you can see, it gives you the pretty good score with this as well. So the demo, back to the demo. So it's basically running the native password strength calculation from Dropbox from a while ago, and also the WebView based one and the JavaScript engine. Now the JavaScript engine and the WebView does some warm up at the first run, so more realistic if I run it again. You can see how much it took to run the password calculation. Of course, the native one is the fastest, but the other two are not too far. And even then, I would like to highlight that with the JavaScript engine implementation, if you check it, I basically taken advantage of the multiple isolated environments. So all of the calls are going into a new environment, which you don't have to do. If you don't worry about the different JavaScript accessing each other, you don't have to do this. But how this is working is that you create one sandbox This is how the JavaScript engine is initiated. In this case, I made it lazily, so only the first access. It creates this create connected instant async, and then you can use it to create isolates. This is what I talk about, the multiple isolated environments, and you don't need to create new one for each and every run, but that's why it had the performance penalty. However, this one has the security advantage. It's a trade-off between performance and security. But this one, I open source this so you can check it out and compare it with the other two implementations, the native one being, of course, the easiest, and the WebView one is quite complicated because of the callback-based API. So with that, we arrive to the takeaways. I would like to say think twice before using WebView. There are more modern technologies available in many cases, but I don't want to seem short-sighted, so there are still good use cases for a WebView. For example, if you have control over the content that you want to display, like for example a messaging application or well, the messaging application maybe not a good example, but if you have your own content to be shown as part of your UI, WebView is still the best component or best technology to use. But you can think about progressive web applications and Chrome custom tab I talked about last year. If you want to show, if you want to display a UI in the application, you can even customize that, and that will run by or created by the browser. So an instance of a browser will be injected into the task of your application, and that will have sandbox, so it won't be able to access your application. Use the JavaScript engine if you want to execute JavaScript. Of course, if no network access is needed. And try to package the scripts within your application so you can trust them or load them from trusted sources. Again, restrict the JavaScript bridge as much as you want, and I always want to say, do threat modeling. Basically create a diagram of your application with the different trust levels, your native code being the most trusted and the code running in a WebView, for example, with less trust. And every trust crossing, you should investigate and see what kind of attacks may be possible and what kind of mitigations you have. Finally, remember that HTTPS is not the only UI scheme, and use real-time access control, directly calling the getURL method of the WebView before sensitive operations. With that, I would like to thanks for your attention. I would like to plug again my secure WebView library that I introduced last year. You can check it out. It has the secure default configurations on all Android versions. Well, it's still only available via Jetpack, but at least you can make sure you can be sure that it's loaded from the GitHub resource repository. But it also has the CC0 license, so it has no license. You can take it and run away with it if you are not confident enough to use that on your application. Yep, and thanks again. If there's any questions, I'm happy to answer. Thanks. So, any questions? Go ahead.
Did you consider the add web message listener instead of the add JavaScript interface to facilitate communication?
Sorry, which one again?
Add web message listener in the Jetpack library allows you to set up asynchronous communication.
Yeah, I forgot to mention, you're right. Last year I mentioned that the Android WebKit has much better APIs. Yeah, you're right. Yeah. That's a good call out. Thanks for calling it out. Yeah, check it out. The Android X.WebKit library, it has better callback methods. Thanks. Any other thing? Okay then. Sorry, go ahead. Secure way to pass the access token. So is there a secure way to pass the access token to the WebView? That's the question. Well, it really depends on the architecture of your application, whether it's a hybrid application or what. So yeah, let's talk about talk afterwards if you are okay with that. So yeah, thanks. Anything else? Okay, then thanks again. Have a nice rest of the day.